Hello, my name is Vincent. Today I'm here to talk about how to reduce the carbon footprint of a residential or an office building construction. Is everyone sitting comfortably? I'm ready when you are. You might not be aware of this, but the embodied CO2 impact of the building structure, which means all the CO2 emitted in producing materials, is a significant part of a building construction's carbon footprint. The main part of this CO2 impact is related to the floor's construction. So let's go. Compared to traditional alternatives, post-tension floors, called slabs, can have a significant impact on carbon and waste savings in a construction project, as well as on overall embodied carbon. The main reason is the artificial introduction of a favorable state of forces opposite to gravity loads. Post-tensioned slabs, PT slabs for short, allow for a significant reduction in the thickness of the slabs with less concrete and in the steel ratios when compared to traditional in-situ reinforced concrete solutions. Let's compare three concrete cast in-situ options to identify the least embodied carbon-emitting solution. Depending on the countries, some solutions are more commonly used than others. So here they are. The reinforced solid concrete flat slab. The solid PT flat slab, which reduces the slab thickness and the overall height of the building. The internally voided PT slab. These slabs are voided internally to reduce both their self-weight and their consumption of steel and concrete. The slabs can be voided internally, either with rectangular polystyrene blocks or with plastic spherical or ellipsoidal balls inside the concrete. This is why we also call them sandwich slabs. Voiding the slabs is pretty common for both reinforced concrete and post-tension concrete slabs. Now, let's have a look at the global warming potential of the different components of each solution and their overall consolidation. For this study, we've got 5 slab configurations, all with typical loads for offices. On the one hand, we have analyzed 2-way configurations for an 8x8 square meter grid with 6 spans in each direction. Both a solid flat reinforced and a solid flat post-tension slabs have been considered. Same for a 10x10 square meter grid and for a 12x12 square meter grid. For this third case, we've also analyzed an internally voided slab solution. On the other hand, we've analyzed 1-way configurations where the main span in one direction is larger than the span in the second direction. A 12x8 square meter grid and a 16x8 square meter grid. Yet, for this last type of grid, we consider that to be outside the range of reinforced concrete solutions. At this point, it might be relevant to share a few details about how we compared. To be fully objective and to simplify this comparison, PT components other than strands have not been considered. This means ducts, anchorages, and grout. This could multiply the PT part by around 1.3. In real life, things can vary according to projects or countries. But once again, for the sake of objectivity, let's consider that we use the same concrete for all options. The quantity of materials, PT and rebar, mainly depends on the local standards and codes. For this study, we've used the Eurocode, which so far doesn't allow for green concrete for PT slabs. According to the Eurocode, it is common to use concrete with a high percentage of clinker, cement type CEM1, that has a higher carbon footprint. For reinforced slabs, we can use green concrete, which can be less carbon emitting. Here, for the comparison exercise, all concretes are type CEM1. So what can we notice? First observation. The post-tension concrete slab option is less carbon emitting than the traditional reinforced concrete slab by about 25% in the slab itself. This self-weight reduction allows for an optimization of foundations, columns, and walls, and brings an extra reduction in carbon footprint, yet not considered in this analysis. It might be done with other codes than the Eurocode, but in any case, there's always a gain. In a nutshell, PT slab is definitely a sustainable solution compared to traditional reinforced slab. Second observation. PT voided slabs, that can also be PT waffle slabs or ribbed slabs, allow for additional savings in carbon footprint. The effect of self-weight reduction combined with the effect of post-tensioning provide very efficient solutions in terms of low CO2 emissions. In fact, the combination of voiding with post-tensioning is the most sustainable choice when we work with cast in situ slabs. I've just realized I mentioned waffle and ribbed slabs alongside with PT voided slabs. Maybe I should quickly explain the difference. With the waffle slab, the installation method is slightly different from the internally voided PT slab. Here, we place the voiding elements directly onto the false work prior to assembling the steels and pouring the concrete. The ribbed slabs, that both exist in reinforced concrete and PT concrete, are specifically used for the one-way slabs. The voids in the slabs are placed to create a ribbed one-way solution. This solution has larger benefits in the reduction of consumption of materials and in the reduction of carbon footprint. That's it. Of course, the choice of a slab solution depends on many criteria, but the carbon footprint is an important indicator to explore and consider in your decisions. I thank you for your close attention today. I tried to be as clear as possible, but if you need more information about solid, voided, waffled or ribbed post-tensioning slabs, don't hesitate to contact VSL, who is a specialist in the design and build of these low-carbon solutions. Thank you once again for watching.